Let's import data from WebSoc to Mathematica. So let's copy the URL. And let's go to Mathematica. And let's say import. And that looks pretty good, but notice that what I wanted to import was math data. And then what we get here is not math data. And I should have been suspicious from the very beginning, because look at how simple the URL is. This doesn't indicate anything about being math department specific. So we need to find some other way of importing this data. And so how I've chosen to do it is I went in Chrome, I went to this view source code. I got the HTML code for this page. And it's not always going to be the case that the HTML code will contain all the information. For example, if the web page was generated using JavaScript, then probably the HTML code is not going to be sufficient. But in this case, it is. So rather than importing from the web, I saved that to a local file. Let me show you. Here I saved it to a local file in a basic text editor, and you can see that it's a very long file containing that HTML code. So let's import that local file that I saved before the video started, and I just named it websoc.html and put it into this same directory, this videos directory. And let me name the result of importing this WebSoc. So that's not importing from the web, that's importing from this local file that I had saved. And let me try to convince you that this is a very long data that we have here, that the data is very long. It's a better way to say it. So let me do a string split of this WebSoc. Okay, it's a string. And let me split it at every line break. And one way to indicate a line break as a character in a string is to do \n. So this is saying we're starting with a single string, and we're going to make it a list of strings where we start new inside strings everywhere that there's a line break in the original string. Okay, and let me call this, how about lines? Okay, and let's see how long this is, length of lines. So that tells me that there are nearly 6,000 different lines in that HTML file. And that's not just like word wrap lines where the text editor displays a new line. It's actually lines where it's specifically a character saying start a new line here. And yeah, let's work our way towards getting data out of this. So let me show you how we're going to use this lines. And one thing I like about it is that it's going to make the data easier to extract from. So let me do cases of all x in lines. So all x such that, and x, it's going to be a string. And so let me do string contains q. And eventually I want all the professor names. But let me just start with a single one. And so notice that all of the names are capitalized. And I'm going to use Professor Pelayo's name. He's the advisor to the data science concentration. So I'm going to use all uppercase Pelayo here. So all x such that that string x contains uppercase Pelayo. And let's see what shows up here. So it's not so easy to work with, but what's the length of this? Okay, great. So that's a good sign. So let's go back and look at it. And let's just choose a random one, like how about this one? And so there are supposedly 11 strings inside of here, and I'm just going to choose one of them. And this is a string, so you should be nervous about all these different quotation marks inside of it, because remember, quotation marks have a very special meaning inside of Mathematica strings. They mean this is where a string starts, or this is where a string ends. Okay, let me copy this. And let me hide this information over here. And Now let me use another function called string cases. So this is going to go through WebSoc, and it's going to look for that string that I just copied. And notice that all of the quotation marks from the original string, they got replaced with / quotation mark. And that's really good, because what that is doing is that's telling Mathematica, this isn't the special character start a string or end a string. This is like the specific string character quotation mark. So that's like a subtle difference. This is saying string begins here. This isn't saying string ends here. This is just saying, give me the character string. So I'm asking, go through that original. So the WebSoc, it's not a list. Okay, lines was a list. WebSoc is just one giant string. And it's saying, go through that and look for this type of string here. And let's see what comes up. So it's a list, like cases always returns, but it's just a length 1 list. And why is that? Well, the thing I was searching for was so specialized. Okay, it had like this special course number, had Professor Pelayo's name, had this time. We shouldn't expect that to show up more than once in the HTML code, but I can use this as like a template. So let me delete some of the last part. Like let me delete how about to there. And let me search for this. Okay, still only shows up once. And yeah, we should expect that this very specific course code only shows up once. But let me replace this course code. Let me replace it with, so let me write it and then I'll explain what it means. So this quotation mark is saying stop the string. This tilde is saying put the next part right afterwards. This is saying any string of any length. This is saying put the next part right afterwards. And then this is saying start a new string here. And I'm going to use that a couple times, so let me copy it. And what I had deleted here was the number, the course number. So let me remind myself that this underline, that stood for a course number in this case. And this A, I believe that stands for what the lecture code is. So let me replace that also with just anything. Okay, so this is, I've replaced the A and I say, okay, any string of any length can go here. This 4, I think that's the number of units. Let me also replace that. And here, this R Pelayo, let me also replace that. And I want to keep that. I want to be able to remember what the name was. So let me say the anything, let's call it name here. And let's see what happens when I try this. So I got something, but the something I got is huge. And what's the problem? Well, here in this string cases, it's going to allow these underlines to be extremely long. And so by default, string cases always looks for the longest match. If instead I want to look for the shortest match, I can wrap it in this phrase, shortest. And so this is looking a lot better. So see, here is one entry in this list. Here is another entry in this list. And like, let me name this. Let me call it, how about extracted? And I'll put a semicolon to suppress the output. And let's see how many things were found. Found 70. That sounds pretty good. And so let's look at it again. Here's the extracted. And I don't really care about most of this data. All I really care about is the number and the name. So after this shortest, let me say replace this with number followed by name. And let's look at it. So here's number followed by name. Here's number followed by name. Here's number, and then it's a lot more complicated. So let's see if we can figure out what went wrong with that. So I think the thing that went wrong was that I should have replaced this lecture part here. So let me copy this, and let me replace that lecture. So now instead of having to say lecture, it could be anything. Okay, I evaluated it again. And now that's looking a lot better. Let's look at it in table form. And there we have the information I was trying to extract.